In the trial, Smart Manufacturing and Industry 4.0 Use Cases and Living Lab, we consider two applications to be demonstrated. Fully automated indoor logistics supply chain. Today, handling and transport of material is performed manually every 30 minutes. By utilizing a 3D vision camera for bin picking application, integrated barcode scanner and collaboration between different robot systems, we aim to fully automate controlled material picking from auto store and autonomous transfer to the production line, human-centered indoor factory environment safety. This use case will provide a high-precision AGV localization layer, merging real-time localizations info obtained from cognitive sensors, safety cameras, radar, and LiDAR. A high-speed and ultra-low latency TSN private wireless network will support massive data uploads to the edge cloud facilities, where AI functions will detect the position of each body. The concept for both application in the trail was developed. Current activities are the concept implementation of a Servius transport system to realizing the floor jump. Initial situation 1. The required SMD materials are requested from SARA Standard Automated Replenishment Application in the AutoStore warehouse system and made available at the 2 removal stations. 2. The operator removes unsorted SMD reels stored as bulk goods. 3. The barcode is scanned by the operator with a hand scanner. 4. The operator places the SMD roll in a KLT. 5. The operator places the KLT on an AGV. 6. The AGVs drive the materials to the respective production lines. In the future situation, Step 1 and Step 6 stay the same, but the middle steps change from manual to automatic. 2. A 3D vision system for bin picking applications is placed above the removal station and gives the correct picking position to the cobot. 3. A cobot scans the barcode of the SMD reel. 4. A cobot grips the right SMD reel and places it directly on an AGV. The initial situation enables the material transport via AGV from the AutoStore to the SMD lines in the production area on the same floor. 6. AGV passes material to a temporary store next to the line. 7. After the material has been handed over, the AGV drives back to the AutoStore for a new load. The future situation enables a floor jump and therefore also an automated material transport to the other production areas on a different floor level.
SARA, short for Standard Automated Replenishment Application, is an Industry 4.0 solution on the shop floor. It continuously monitors the short-term production scheduled sequence and automatically requests components from the warehouse for the next replenishment cycle based on the real-time consumption. In the SARA web application, the stock situation for each feeder can be tracked online. Basis for the replenishment calculation is the short-term production plan and actual stock. The SARA application determines the demand for every line and feeder under consideration of the actual cycle times of the machines. Depending on the plant-specific time to deliver the parts from warehouse to the line, the coverage time is considered in the calculated demand. The SARA core module sends the material request to the warehouse system, SAP, if the demand can't be covered by the actual stock. SAP creates automatically a transport order and sends the information to the SARA system. Once the order is picked from the warehouse, the confirmation is done in SAP. This update can also be seen in SARA. It allows the operator to trace the material status in the SARA web browser. The Automated Guided Vehicle, short AGV, delivers the components to the lines. The material is available for production and next replenishment cycle restarts since demand is recalculated constantly. The short-term production scheduled sequence is maintained in the SARA Sequence Manager, short SSM. The remaining quantity to be produced is constantly updated by actual machine data. With the SSM, even components for forthcoming setups are ordered in advance.
The automated sorting and booking station work in sync with SAP and Product Lifecycle, PLC, ensuring real-time booking. The process starts with the image recording of material in AutoStore box. A 3D sensor placed over the box takes pictures of the content inside the box and evaluates them with the help of AI. The sensor uses light field measurement and has been evaluated specifically for this application. Due to the various surfaces of materials, especially transparent and mirroring packaging, it was not possible to identify material with existing systems at Continental. The camera software transfers all relevant data to the PLC. Part of this data are the position of material, path of robot, and size of material. The size of the material is relevant so that the gripper can set to the correct size. To generate the AI-based bin-picking neural networks were trained completely in-house to identify standard SMD reels, FR four-board packages, etc. More than 5,000 pictures of various material packaging and forms in-house were trained. Similar-looking material is also very well recognized and contributes to the detection rate of 99.9%. Due to the fact that this is standard material from the world market, recognition using a classical algorithmic approach is not possible with the high recognition rate. The AI therefore not only recognizes the pick position, but also provides the following information: material category, pick position, barcode of the selected material, and number of materials in the image. In the last step, the robot places the reels inside a transfer box. The robot always has 2 free transfer boxes for placing the materials. If a new box is needed for a new destination, it is provided via one of the 2 box towers. A total of 10 sorting targets are available to the robot. When the robot is done, the transfer box is made available for further transport for the Automated Autonomous Guided Vehicle, AAGV, via a conveyor line. The transfer boxes are then automatically transferred to the AAGV, which brings it to production.
The vehicle dynamically calculates the transportation route. Obstacles can be passed because of the detection by the internal sensors. At the defined unloading point, the AGV stops. The reels are unloaded and now ready to be used in the machine. For the feeder running out of material, the next reel is spliced. With the scan on the machine, the movement of the parts are booked in SAP and SARA. Quantities in SARA are updated. The next upcoming demand is recalculated.
The automated sorting and booking station scans, sorts and handles all reels, dry packs and PCBs automatically. The robot sorts the reels into boxes with the help of scanning stations, and these reels can then be sent to the warehouse or production. The ASBS consists of conveyor system to transport parts, scan gate to register them, robot to sort and put away the parts, and box station for automatic supply of boxes. The process starts with the image recording of the material in the AutoStore box. The camera software transfers all relevant data to the PLC. The data includes the position of the material, the size of the material, and the label information. Also, the project automates the booking in SAP from warehouse to production. From a technological point of view, the Smart Manufacturing and Industry 4.0 pilot aims to implement and validate the innovative architectural solution proposed by NEMO in order to fully automate the production workflows. The solution developed within the pilot will achieve 2 major objectives at the level of process automation, namely monitoring and detection on the manufacturing workflow and ensuring the manufacturing safety procedures. The NEMO platform will provide the functionalities of 2 monitoring systems through equipment and sensors, namely bin picking system for the automation of the manufacturing process and sensoric system for assessing the working environment. At the level of the communications infrastructure, an IoT/5G time-sensitive networking network will be implemented, and the orchestration of services will be done through intelligent open API algorithms. Within the trial, emphasis will be put on implementing next generation of IoT applications related to AGVs to human operators, collision prediction, detection and avoidance through real-time positioning and federated ML hosted locally and in the 5G Wi-Fi edge. The innovations of the trail are combined 3D vision, heterogeneous networks, and semi-autonomous transfer learning, enabling fully automated SMD components recognition and transfer to production site. Improved collision protection for employees in highly automated production areas and enable closer cooperation between people and machines. Improvement of mass production in factories with a high degree of automation. A successful implementation leads to objectives like more flexible material removal, better just-in-time delivery, more efficient use of employees and improved ergonomics. Expansion to include also back-end production.